Before we get back into the editor real quick, we're going to talk about some concepts. So we're about to start using some code, and we're not going to actually do any live coding in here. So sorry, I know most of you this time around were programmers. Usually it's more 50-50. And the way I like to think of it is if you're a programmer, then you already kind of understand the code and you don't care. And if you're not a programmer, then you don't understand the code and you don't care. And so we generally don't do live coding. So we're going to talk about some scripts. All of the scripts in this project are fully commented, all the lines, every little bit. So we don't spend a lot of time going line by line through the code. I just want to explain some of the concepts, what's happening inside this project, some of the stuff we're going to be doing inside the scripts for these players. The first thing is this concept of input. Right? So obviously we have our horizontal, vertical input, space bar, whatever, but we're also building this for mobile, and who knows, maybe we want to use game pads or joysticks or whatever. So instead of simply using the input class, we are going to wrap our input in a class called player input, which is simply responsible for pulling all the different types of input and creating some variables that we're just going to use. It's going to have like horizontal movement. Are you pressing the jump key? Are you holding the jump key? Are you pressing the crouch key? Are you holding the crouch key? And that's really what we care about. So we can just say, hey, specialized input class, are any of our input devices doing any of these things? All right, and so then it's just modularized. We can add on to that. Now, as far as the character goes, we have a couple of things that we're doing inside the script. The first are these environment checks. Every frame, we're going to kind of be building some awareness of the environment around the player, right? 2D platformer games, or any platformer game, especially games that have a lot of traps and difficulty and require a lot of precision, it's key to have really good, really strong controls, fast responses, a little bit of tricks in there to help the player, and we want to make it so that it feels really sharp, really accurate, no lag, and very, very accurate. So we're going to be doing these environment checks. And so the first environment check we're going to be doing every frame is we're going to be determining, one, are we on the ground, and is our head blocked? So to determine if we're on the ground, we don't want to just send one ray cast down the center, because then it becomes easy to fall off the edge or get stuck because we're not on the ground, even though we're still on the ground. And so we're going to do 2 ray casts, one for your left foot and one for your right, and that will determine if either of those are touching the ground, you are on the ground. Also, when we're crouching or we have blocks directly over our head, we don't want to be able to stand up or jump into the blocks or whatever. And so we're going to do a check that just says, hey, is there anything over our head? If there is, we can't stand up because we wouldn't fit, right? And so we need to do those checks. I also have like a green diamond there to show you that even though we're using sprites, we are setting the pivot at this player's feet. So all code, all positions, all offsets originate at the ground, right? And so 0, 0 for this character, the pivot of this character is right in the center of it, at the ground, at the character's feet. All right. The other thing is we need to determine, how do we do wall grabs? Wall grabs can be complex. What counts as a wall grab? And so wall grabs, in this case, are a little more complex, requiring 3 ray casts. We also want to note that we're only doing wall grabs when we are falling. You can't wall grab on the way up, only when you're on the way back down. And so there are basically 3 types of surfaces we interact with. And so we just created this graphic here to show you, like when you have a flat wall, obviously you have 2 horizontals that hit a collider and a vertical that doesn't, and then a concave edge, and then a ceiling. And then finally, in the lower right, we have an actual ledge. And in order for an actual ledge to be grabbed, those are the 3 ray casts where, at eye level, we hit the wall. Vertically downward, we can reach the top of the wall, and nothing is blocking the area above the wall. If those are set, then we can grab onto the wall, and we have a successful wall grab. We've tried this a bunch of different ways. This is a great way to do this. It works whether or not we're using a composite collider or individual colliders or any types of colliders. This algorithm will get you accurate wall grabs every single time.
And it's approved by Drake.
And it's approved by Drake. Not actually, so don't sue us. All right, so then for movement, we have a few types of movement, all right? So the first type of movement is our ground movement. And our ground movement works like this. So the character, Robbie, is 2 blocks tall while standing. Actually, a little bit shorter than 2 blocks. 2 blocks would be a height of 2. And remember, we set the collider to 1.8. So you can move under and have a little bit of leeway in moving around. So it feels accurate there, but forgiving. And you move at a speed of 100% when you're standing up. When you're crouching, you're only 1 block tall, or a little bit smaller than that. And you move at a third of that, or you 33% speed. By default, you can adjust all of this to the code. We have a bunch of variables exposed to handle that. But our ground movement, very simple. All right, and then we have our midair movement. And for midair movement, we have 3 types of jumps. People like variety in their jumps. They like to be able to plan their jumps and kind of not necessarily jump to maximum height every time they tap the bar. They want to have some vertical control. And so the way we've set this up is when you tap the space bar or the jump key or whatever that happens to be on mobile, the screen or whatever, you are going to jump with some initial upward force. That's a fixed amount, some initial upward force. After that, the window will be set, a period of time where if you keep holding the key, incremental smaller bits of force keep getting added, allowing you to reach a higher height, right? So if you do a jump and hold, maximum length, you will jump 4 blocks high, all right? So you can grab that 4th block, all right? And then finally, if you crouch first, you get a larger initial boost at the same jump window. So then from there, if you hold, you get the same incremental force added for the same period of time, but that allows you to reach 5 blocks there. And this is all set up to mirror exactly the actual Robbie Swift hand game, all right? And so we've set this up so you're getting the actual mechanics, exactly how it feels, that sort of thing. Also on the topic of midair movement, there's no difference between jumping and falling in this game from a mechanic, a logical, any standpoint. You're either on the ground or you're not. It's irrelevant whether you're jumping or you're falling. All right? A jump is a fall that you meant to do. That's the only way we're controlling this. We're using our vertical velocity to determine, what stage in the air we are for animation's sake and for wall grabbing, because we can only wall grab while we're falling. But otherwise, you're either on the ground or you're not. The rest doesn't really matter. So jumping is just falling up, basically, and then you'll fall back down, is all it really is. And that simplifies a lot of the code, a lot of the animation. We're going to see we're actually going to make the animations for jumping. You're going to see exactly how that all works. Okay, so let's get back over to Unity. Let's look at some of these scripts. We're not going to spend a ton of time on it. Obviously, if you have questions during the breaks or whatever, happy to answer those. All the lines are commented. But we don't want to spend too long just talking and studying these scripts. So go ahead and switch back over here. So the first script I care about is this player movement script, as I had mentioned earlier. And let me just sort of zoom in. Zooming is not working, so let me zoom this way. All right. So this script, I'm not going to go into great detail, but one thing that's key, one thing that's very important, and this is just a general rule in Unity, is all the inputs are calculated, are updated, are recorded in our update method, right, which runs as fast as it can, But we generally do our physics inside fixed update, which runs at a very fixed time interval, roughly 50 times a second, right? And so update and fixed update can get out of sync. And so you generally have to come up with some way of recording inputs during update, but then using them during fixed update. What happens if you get 2 updates back to back before you get a fixed update? Well, then you've missed some inputs. So in your game, you hit space to jump and you didn't jump, and now your game feels laggy and players get upset and whatever. So we've set this up to keep our inputs in complete lockstep, so that will not happen. And the key component to that is setting up this execution order. So this attribute right here basically states that this script, the player input script, will execute every frame before the other scripts. So we're going to get all of our input first, and then the other scripts can use it. So that's important. That's why we have that there.
I think that's a new feature as well, or very recent.
We've been able to set the execution order through the UI for a while, through the script execution order in the options. The attribute to use in code like this is relatively new, yes. Here we've got some UI control stuff that doesn't matter right now. We'll get back to that when we start talking about mobile later on in the day. And here are the public variables we're going to use to determine input. So where you might normally do like input.getAxis horizontal to get your horizontal input axis, here you'll just do player input dot horizontal, and that's going to give you the same thing back. So we're just wrapping up that class for you. And inside update, we're basically first going to clear our inputs out. And then here's this thing for game manager. We don't have a game manager yet, so this line isn't going to do anything, but eventually we will. And when we do have a game manager, this is going to say, hey, game manager, is the game over? Because if it is, don't do anything with input, so the player stops moving. And then we're going to process our inputs, and we want to clamp our horizontal values. This is the other key component to keeping our inputs lag-free, preventing loss of inputs. All right, so we are going to have this ready to clear inside fixed update. So what this means is, update can run 1 time, 2 times, 6 times before fixed update runs, but update is just going to accumulate inputs, all right, instead of like clearing them out. We're going to just gather inputs without removing any inputs. And then once fixed update runs, we're sure that both update and fixed update has had a chance to use those inputs. The next time around, we're going to clear them out. All right, so that is how we know we never miss any inputs. That's a great solution provided by James over there. Credit where credit's due. Thank you, James. Worked fantastic. So in clear update, or clear input, which we're doing every update, we only clear if fixed update has run. If it hasn't, we don't clear it out. We just keep it. All right, but when we do clear it out, we just reduce it like that. And then inside our process inputs, I'm not going to get into touch inputs. We'll talk about that later with mobile. But with process inputs, we're basically saying, hey, horizontal, let's accumulate. So you'll notice we're not saying horizontal equals input.getXS. We're saying horizontal plus equals. And we're saying jump pressed doesn't equal input.getButtonDown, but it equals jump pressed or input.getButtonDown. It accumulates our inputs. All right, so that's how our inputs are working there without going into too much detail. The most major script we've got today is the player movement. It's where we're putting all of our time, all of our coding effort, because it's the most important part. If you don't have smooth player motion, the rest of it is irrelevant. All right? So we have a lot of work going on in here. The first variable, the draw debug raycast, is purely for debugging inside the scene view. We'll see what that does here momentarily. And then we have a lot of variables that just control how Robbie moves. And these are all exposed in the inspector. They're all public variables, so you'll see them in the inspector. You can modify them. Maybe you want Robbie to move faster, slower, jump higher, whatever. But these are all exposed. Some of the highlights, obviously we have our speed, the crouch speed divisor. That's why our speed is 33% of regular speed when we're crouching, because we're divided by 3. And we have this interesting concept here called coyote duration. All right, so it's coyotes in our game. Who here knows Wile E. Coyote? I don't know if there's a German name for Wile E. Coyote, or if it's still Wile E. Coyote. No idea. But Wile E. Coyote, as everyone knows, never falls until he looks down. Right? He just runs off a cliff, stays in the air, then looks down and goes, oh no, and then falls. So what happens in these platform games is as the player's running, they hit the space bar to jump right after they've left the ledge and they fall to their deaths. Now that's their fault. They don't see it that way. They see it as, I was still on the ground and this game sucks, right? So we use coyote time, and coyote time is just a little window where, okay, you're not on the ground anymore, but if you press jump in this window, we're going to pretend you were on the ground and we're still going to let you jump. And that's going to make the players go, oh, this game is great, it's super responsive, and I make my jumps every time and it feels super good. All right, so we have a little coyote window, and it's not a lot. It's 0.05 seconds. All right, that's not much at all, but it is enough that if you just miss your jump, you're going to still make your jump, and people really like that.
And at the very end of the training day, don't do this now, but at the very end, try removing it and seeing how much the difference is. Just that 0.05 really.
It makes a bit of a difference, yeah. Here's our initial jump force we talked about, the jump boost when you crouch. And then we have our incremental jump force, a much smaller amount. One thing to be aware of, too, is when we're hanging on a ledge, we have a couple options. We can either press crouch or down to let go, or we can press jump or up to jump off the wall. And so we just have a set force that we can jump off the wall with, and that's our hanging jump force there. Here we have our environment check property, so that's just determining, okay, what's our foot offset, how high is our eyes, how far can we reach, little things like that. They're just little tidbits that you modify to just adjust the feel. Obviously, if you change the size of the Robbie character, you'd modify these values, but otherwise these values are just determined as good values for wall grabbing and where your feet are and things like that. And we specify what the ground layer is, so we know, obviously where the ground is. These status flags are used simply in the inspector. As I'm playing, I can look in the inspector and see these statuses to get some understanding of what's going on with my character. We're also going to use them with our animation script a little bit later to control our animations. All right. One more thing in these variables that's worth knowing, we have different collider sizes when we're standing versus when we're crouching. So instead of recalculating that every time we stand up or crouch, we're just going to store those values in these vector 2s here. And in a couple of places, I use a very small amount, so I have a variable here called very small, or small amount, that is just a constant that I utilize in a few places. Inside start, we're just getting some references. We're going to record our original scale, our player height. We're going to record and calculate, our player's body size, our standing collider size and offset, and our crouching collider size and offset. And then just like the slides, we've got these 3 sections inside fixed update, our physics update, the one that happens 50 times a second. We're going to do our environment check, our physics check. We're going to do our ground movement, and then our mid-air movement. Our physics check, we're going to say, okay, let's do our ground check. Left and right foot. All right, let's see, let's raycast out. Did either my left or my right foot hit the ground? If so, we're on the ground. We're going to do a head check, and if our head check came back true, there's something directly above our head, so our head is blocked. You notice we're not really doing much here, we're just setting some flags, we're setting some state. And then finally, the grabbing. So as I said before, there's 3 raycasts, right? Those 3 raycasts we saw in that graphic. So we need to say, okay, first off, did we find a ledge? Is there a wall directly in front of us and a ledge in front of us? And then is our hand blocked, all right? So those are those 3 raycasts, which leads us to a bit of a fun little if statement here to determine how do we grab a ledge. Well, there's a few things that have to be true. First off, if we're not on the ground, we're not already hanging on a ledge, we are on our way down, so we have a negative y velocity, and there is a ledge there, there's a wall in front of us, and our hand is not blocked, we have a wall grab. All right. Now, you don't necessarily, for efficiency's sake, you don't necessarily have to do all 3 of those. I could have said, is there a wall there? Now is my hand blocked? Now is there a ledge there? So it's more efficient. However, I have a special wrapper that I'm using that allows us to draw these raycasts in the scene view, and I just wanted them all to render. So that's why we do all 3 at once, even if we don't necessarily need them. If we find a wall, all we're doing is we're going to move our body to that wall minus a small amount, because if they directly overlap, then physics is going to push them apart again, which is going to make your character jump super high. We're going to move the character down to be on the ledge there, and then we're going to set our rigid body to static. So the player is no longer affected by physics in any way, it's just hanging there. And we'll set it back to dynamic when they let go. Because while they're on the wall, we don't really need them to be physically active in any way, right? They'll still have collisions and stuff, but they're just gonna chill there. Ground movement, basically, if we're pressing crouch, but we're not currently crouching, we're gonna start crouching. If we release crouch and we're still crouching, we're gonna stand up. If we're crouching and we jump, we're gonna stand up. Otherwise, we're recording our velocity, and we're gonna determine if the sign of our velocity and our direction are the same. An easy way to do that, so let's say I'm heading in a positive direction and I'm facing a positive direction, you know, a positive number times a positive number is a positive number. If I'm heading in a negative direction and I'm traveling in a negative direction, a negative times a negative is a positive. The only time they don't match is if I'm heading in a positive direction but I'm facing a negative direction, or vice versa. That gives me a negative, and I know that I'm facing the wrong way, and I need to change the direction that I'm facing. And so we just call this flip character direction. Otherwise, if we're crouching, we reduce our speed. We apply this to our rigid body, and if we're currently on the ground, we record what our coyote time window is. We constantly update that so that when it's time, we'll know that we can jump. Mid-air movement, if we're currently hanging and we press the crouch button, then we're not hanging anymore and our rigid body becomes dynamic, so we just let go of the wall. If we're hanging and we press jump, we're not hanging anymore, our rigid body is dynamic, and we add our jump force. Otherwise, if we press the jump key for the first time, and we're not currently jumping, and either we are on the ground or within our coyote time window, we initiate a jump. For crouching when this has happened and our head isn't blocked, we add our initial jump force, our crouching jump boost. Otherwise, we are not on the ground, we are jumping, and we add some force. Otherwise, we're currently jumping and we're holding the key, we add incremental force, and we record, and we say, hey, if we're outside of that window to continue holding the space bar, then we're no longer in this jumping state. We're no longer going to keep boosting ourselves up. One interesting thing we do here is we cap our maximum fall speed, because, you know, if we have a level where we might want the character to fall down a long shaft or something like that, we don't want him to go too fast. The camera will have a hard time keeping up, and so we just cap that there.
And also, you may be too fast, you then hit a platform, then
go
slowly go through it, depending on your device that you're playing the game on.
Exactly. When we flip the character, all we're doing is flipping its x scale, positive and negative, which has the result of flipping our character, right? So we're just scaling it 1 and -1 in the x direction, or the x-axis. Crouching is just determining whether or not we're crouching, and we're just going to change our colliders for crouching. Standing up can only happen if the head is not blocked, so we return if it is, and otherwise we apply our standing collider. Finally, I've wrapped up the raycast, so instead of calling physics 2D.raycast, like I have here, I created a method called just raycast that's shorthand, so we don't have to pass in as many variables, because we know we're using the same transform every time and all that stuff. And it gives us this, if we want to draw debug raycast, let's draw that raycast in the scene view. All right, So that's a lot of code. Let's see what this does. So here I have Robbie. There he is. So I'm going to add these scripts. So I'm going to go down to my project view, and I've got this scripts folder. And inside my scripts folder, I've got player input and player movement here. And so I'm just going to drag this. Now, the inspector is getting kind of full, but I could just find any spot where it turns blue here. Just drop it. So I've added my player movement script. I could mess around with these values. I'm going to leave these all as default, but these are how you change speed and all these things right here in the inspector, so you don't have to go into that code if you don't want. The only thing I have to do is for ground layer, I have to say, hey, the platforms are my ground. That's what I'm looking for. Now, in order for my inputs to work, I just need to drag my player input script onto here as well. I don't need to do anything to this script, just leave it as it is. And now, if I just hit play, I am going to have a moving Robbie. And so one thing I can see here is I can see the raycasts. I can see there's the head raycast, and there's the wall grab raycast that I could turn on and off with that draw debug raycast. You can see that as I crouch, my collider changes size. Now, Robbie himself is not changing. He's still just moonwalking all over the place here. But if I want, I can crouch and phase through a wall for right now. We'll deal with the animations later. And when it comes time to like wall grabbing, if I want to come over here, you'll see that if I try to jump, I can't get quite high enough to grab that ledge. So if I crouch jump, there we go. I've grabbed the ledge. You can see the raycasts lock in there. And then from there, I can jump above and then grab onto that one and jump above. Or if I'm just hanging there, I can press crouch to drop back down or whatever. So my inputs are now working. My physics is now working. We'll deal with the graphics, the animations, all that stuff later. But I have a moving character. So that was a lot of talking from me, a lot of little bits about these scripts. But let's go over what you're going to do for this cycle. It's actually really simple. So in Unity, with Robbie selected, you're going to locate your scripts folder here in the asset on the project view. And you're going to locate player movement and player input. And you're going to drag both of those scripts onto Robbie so they appear as components, player movement and player input. On the player movement script, you are going to change the ground layer to platforms. And then you can try this out by clicking up here at the very top of the editor, the play button. All right, we're going to talk about the play button here in just a moment when we come back. But that will allow you to test your scene out. Be sure to save your scene and then run around and play. We'll deal with the camera and all that stuff here in the upcoming cycles.